Welcome back to part 2 of our first section of notes on rational and irrational numbers. In the first part, we worked on converting between fractions and decimals. In the second part, we're going to talk about square roots, cube roots, and estimating irrational numbers. So, let's take a look. First off, square roots. A square root of a number is the number you can multiply by itself to get the number under the root, or what we call a radical. So you're going to have a radical symbol, and you're going to have a number under the radical. The square root of that number is what number multiplies by itself to give you 16. In this case, 4 would be the number that you multiply by itself to get 16. So the square root of 16, the answer would be 4. A perfect square is any number that has a whole number square root, like the one we just did. Square root of 16 is a perfect square because the square root is 4. To find a square root, we work backwards from the number under the square root. Very important. All square roots have two answers, both positive and negative versions of the number. And that's because 4 times 4 is 16, but also negative 4 times negative 4 is also 16. So we need to make sure we know that they have two answers. So let's take a look at some examples. We have this equation, x squared equals 121. And we need to remember that when we solve equations, we undo what is happening to solve for x. We do the opposite to solve for x. In this case, we are squaring whatever x is. We're multiplying it times itself. That's what it means to square something. The opposite of that is to do the square root. Take the square root of each side. Okay, what I'm left with is the square root of x is what number multiplied by itself gives you x squared. That's just x equals whatever the square root of 121 is. Okay, in this case, we're looking for what number times itself gives you 121, and that number is 11, because 11 times 11 gives you 121. So when I solve the equation, I take the square root of both sides. I'm left with x equals whatever the square root of 121 is, which is 11. So I have plus or minus 11 as my answers. So 11 or negative 11. Let's take a look at the second one. We have x squared equals 16 over 169. Okay, so again, undo the squared. We take a square root of both sides. When we take the square root of a fraction, it's just the square root of 16 over the square root of 169. So we take the square root of the numerator and the square root of the denominator. Square root of x squared is x. Okay, the square root of 16 we already know is 4. And the square root of 169, so we're looking for what number squares to give you 169, or what number multiplies by itself to give you 169. Since you know it has to end in 9, that really limits our choices. And so the square root of 169 is just 13. So x is positive or negative 4 over 13. This sign just means plus or minus, meaning positive or negative version both work. And we write that before a number when we want to talk about using the positive and the negative version. So again, work backwards, find out what number multiplies by itself to give you the number under the radical. And remember that when you have a fraction, you can just set the fraction up so it's the square root of 1 over top of the square root of the other. The next thing I want to talk about is cube roots. A cube root is similar to a square root, except it's what number multiplies by itself 3 times to give you the number under the radical. So I have x cubed equals 8 over 125. Again, I want to undo this x cubed, so I take the cube root, which looks just like the square root, except there's a little 3 here. And I take the cube root of this side. Okay, and it's the same as the square root, where it's the same. I can do this cube root of 8 over the cube root of 125. Okay, so what number multiplies 3 times to give me 8 over what number multiplies 3 times to give me 125? Okay, so cube root of x cubed is just x equals the cube root of 8 is what number multiplies 3 times to give you 8? That's 2. 2 times 2 is 4 times 2 is 8 over 5. 5 times 5 is 25. 25 times 5 is 125. So I get x is 2/5. This only has one answer, because if I were to make it negative, it would be a negative times a negative, which equals a positive, times a negative again, which equals a negative. So we're end up with a negative, and this number is not negative. So cube roots only have one answer. In this case, the answer is 2/5. Take a second, pause the video, come back after you solve the return, and just check your work with me. Okay, so we have x squared equals 196. Okay, we're looking for what number squares to give you 196. We take the square root of both sides. The square root of 196 is 14. That means that your answer is positive or negative 14. Okay, number 8. I'm going to write this here because trying to fit that in there is too tight. I have x squared equals 9 over 256. I take the square root of both sides, which is the same as the square root of 9 over the square root of 256. Okay, so I have to figure out what number multiplies by itself to give me 9. That's 3 over which one multiplies to give me 256, which happens to be 16. So my answer is 3 over 16. Okay, number 9. I have a cube root here. X cubed equals 512. I work backwards. I take the cube root of 512, and I take the cube root of x cubed. The cube root of x cubed is just x. And so we're trying to figure out what number multiplies 3 times to give me 512. And I will speed forward, and that number is 8. 8 times 8 is 64. 64 times 8 gives you 512. And number 10, I'm taking the cube root of 64 over, sorry for my handwriting. Let me try and write that a little bit neater. I'm going to take the cube root of 64 over 343. So I take the cube root of both sides. So it's what number multiplies 3 times to give me 64. That number is 4 over what number multiplies 3 times to give me 343. That number is 7. So my answer is 4/7. Okay, it's that simple. So the last thing we want to go through is how to estimate ones that are not perfect squares. The square root of 2. There's no number that you can multiply by itself to give you 2. So we can just figure out how close we can get really close, whether it's the 10th, 100th, whatever it is. We may not know the exact answer, but we can figure out a number that's really close to what the square root of -2 or square root of 2 is. Okay, so we start by figuring out perfect squares that are less than and greater than the square root of 2. Okay, we have the perfect square, the square root of 1, because 1 times 1. Okay, so the square root of 1 is a perfect square that's less than the square root of 2. The next one would be the square root of 9, and the square root of 9 is just 3. So we know that the square root of 2 is between 1 and 3. Okay, which helps us to try and figure out about what it is. At this point now, we just start kind of doing guess and check. We pick decimals that are really close. We can square 1.4, which is 1.96. That's really close, but it's smaller. So we can do 1.5 and see if 1.5 is closer than 1.4. So we multiply 1.5 times 1.5, which is 2.25. So we're looking for a number that's bigger than 1.4 but less than 1.5. At this point, we're just going to round to the one that's the closest, and this is very, very close to 2. So we stick with 1.4. And actually, we say that the square root of 2 is about 1.4, and this little squiggly equal sign means about. Okay, so find perfect squares that fit around it, and then use those perfect squares to figure out, and use guess and check to figure out a number that's really close to the square root of 2. Let's take a look at one more example. So we're going to estimate to the nearest tenth for the square root of 15. So again, we start by finding perfect squares that are smaller and larger than the square root of 15. A smaller perfect square would be the square root of 9, okay, which is equal to 3. A larger one would be the square root of 16, which is equal to 4. So we know that the square root of 15 is somewhere between 3 and 4. And obviously the square root of 15 is closer to the square root of 16 than it is the square root of 9. So when we start picking numbers to multiply, we're going to pick ones that are closer to 4 than 3. So we'll start with 3.9. And we'll do 3.9 squared. And when we multiply 3.9 times 3.9, we get 15.21. Okay, it's larger than 15, so we'll go down to 3.8. And you're going to be able to use a calculator for this. So I do 3.8 times 3.8, and I get 14.44. Okay, 15.21 is just 0.21 away. 14.44 is 0.56 away. So this one is slightly closer. So we'll say that the square root of 15 is about 3.9. Not exactly. Obviously, we could keep going. We could go to the hundreds. We can go to the thousands and get a number that's even more accurate. But this just says round to the nearest tenth. So to the nearest tenth, we get 3.9. Okay. I hope this makes a little bit of sense. We'll have time to practice it, and you'll learn to do it a little bit better. Okay. Square roots. What number multiplies to give you the number under the root? Cube root. What number multiplies 3 times to give you the number under the root? And we can estimate by finding numbers that is really close to that square root, but not exactly. Hope you understand. If you have any questions, please ask or comment or do whatever you need to do.